Hello everyone and welcome to this section. All right, so in this section we're gonna start to actually play around a little bit with the Python, with the Jupyter notebook, and we're gonna use kind of OpenCV, which is a very powerful library that we can use to manipulate a lot of images. All right, so let's assume that I have a colored image, okay, which is this image, which is simply like kind of like an image of a road showing different colors. We have some green colors here for the like the greenery. We have some vehicles in here. We have some lanes that are kind of represented in a white pixels. Let's take a look at the image, and I'm going to walk you through the code step by step. And the objective of this exercise is to just take an image. It's kind of like warm up kind of. We're going to take an image. We're going to convert that colored image into a grayscale and actually save it. Okay, very simple example. Walk you through it step by step. All right. So the first step is we're going to import matplotlib. Okay. .image, which is going to be used. I'm going to show you how can we use basically for the pyplot and image as well libraries. And then I'm going to import numpy as np. I'm going to import the CV, which is OpenCV library, which is again very powerful. They're going to show you it can do wonders for us. It can make our life 10 times easier. Okay. All right. Let's run it. So that's kind of importing the library. We're good. Once we see the number, that means we're good. Okay, good to go. Next step is my image. Okay, it's again the image has to be in kind of the same directory that I have, and I have specified. Okay, we wanna np img.image read. When I read the image, I'm gonna specify what my image is .jpg. Okay, and the image we're gonna be read. I'm gonna be put in an image color. Right, that's pretty much it. Let's run it. That we're just gonna load our image, and then if I wanna show the image, I was just going to use, like image show, okay, within the plot library, PLT library. And then we're going to show, okay, the actual image that I've got here, which is image color, right? That will show our image. Okay, looks great. So that's my exact same image that I had before. It looks perfect. All right. And then what if I want to show the shape? Okay, I know that this image is colored image. So I'm expecting to see kind of 3 layers somehow. But I don't know, for example, the dimensions of how many pixels do I have. Actually, you can read it through the image here. You can see that our image is around, let's say, 550 pixels by, let's say, 900, 950, for example, width, right? So let's actually read this. So if I write image_color and I use the shape method to apply on this image .shape, then we can actually tell us, okay, what's the shape of the images? Okay, let's run it. All right. It actually showed us, okay, we have 540, that's our length here, and our width is 960 pixels, and actually we have 3 layers, which makes complete sense. Why? Because it's a colored image. Okay, perfect. Okay, great. The next step is we actually wanted to take the image and convert the image from color to grayscale. Okay, so what we could use is we can use again the OpenCV to perform just color conversion. So what we do is that we can call it, okay, cv2.cvt color, okay, which is kind of, like just, we can convert from, let's say, like different color formats. I'm going to show you how to convert from RGB, for example, to HSV or whatever format afterwards. But here we're just going to do is that we're going to use our image. Here we're going to pass our image, which is image color. And then we're going to use, the method of converting from color _ BGR to gray. So we're just going to move from colored image to a grayscale image. And this basically will return back my image. We're going to call it image gray. Okay. The next step is we're going to plot.image show. We're just going to show my image gray, and I just use the color map gray. Okay. All right. Let's run it. And perfect. Let's actually show me my image, and it looks like a grayscale. That looks great. Again, you guys recall the number of pixels are the same. So we have again 500 or 540 by 960 pixels. However, I should see that the third dimension of a matrix, which is the third dimension, the 3 dimensions or the 3 layers, has to be reduced somehow. Now, why? Because now we have a grayscale image, right? Let's take a look. So if we use again the shape method over the image gray, we should see just a single layer, right? So let's run it. That actually looks pretty good. Actually, we saw like we don't have 3 anymore, like here before. Now we have just kind of like a 2-dimensional 2D, and in each pixel there's just 1 color. There's no 3 colors that represents RGB colors as we had before. All right. Okay, let's take a look at the actual, what if I want to not just, image show will actually going to show me the actual image, will translate the image. What if I actually want to see the actual value of the pixel? Okay, we can do this by just using like image gray. Okay, so if I actually call this kind of, you know, like our matrix per se, if we run it, that will show us actually what's inside it. So if you guys can see here, that will show us, okay, that we have like, you know, like integers of 8, okay? And as you guys see here, we have these are the kind of decimal values that represent the pixel values within it. So we have like say 191 that represent, let's say, a gray color. 187, it's again a gray color, it's a little bit like lighter, okay? If you guys recall, 0 was black, 255 was completely bright, right? So as we increase the number 191, that we're going to like towards the white, okay? Okay, and that's pretty much how can we represent the pixel. What if I wanted to, let's say, actually I got that command mainly specifically because I wanted to view the entire matrix. I want to see like what is that, you know, image we're gonna look like as a matrix. All right, so if we run that command, that will simply, you know, and if we run that command prior to the image gray, that will show us the entire image, full image, okay? All right, so let's take a look. It's taking a little bit of a while because I'm plotting the entire image right now, and that's actually gonna show me the entire image. This is pretty much all the pixels. Here in simple forms, I'm just gonna use this, instead of using like these dots, just gonna show the actual image. All right, that's pretty interesting. As you guys can see here, there's a lot of 200, 213, for example. That means we know it's a lot of bright colors, white colors, not bright, white colors. If we go down here, you'll show there's a little bit of like, you know, like kind of black kind of thing, 70, around 70. You know, if you go down, you would see some, I saw some 34, 33, that means, you know, very dark colors. And keep scrolling down, you know, that's how you actually view the image in a color, in a decimal format, which is fascinating. That's, you know, like, yes, you can see an image, you know, we can interpret it, we can actually see what's happening in the background. Why? Because once we know what's happening in the background, once we interpret it as numbers, we can actually use it moving forward to train, let's say, an artificial neural network, or let's say a machine learning algorithm that can tell me, okay, where is the black, where is the white range? How can we classify images? What are the features that we can get out of the image? And that's the beauty of, you know, computer vision, and when we tie it down, or we tie it basically with machine learning strategies or machine learning techniques. All right, perfect. Okay, that's great. What if I want to save the image? Actually, we can use, again, OpenCV. We're going to use cv2.image, right? And then we're going to specify what's the name of our image. So we're just going to call it image_lane. It's called gray. G stands for gray. And I'm just going to pass, okay, what's the images? So that's my image gray, that I want to save it under the name, under this name, basically, okay? Once we run it, then it should tell me true. That means we're good. And then if you go to the working directory, you can actually find an image. It's called image lane. You should find image lane gray, and that will be our grayscale image. All right. And that's pretty much all what I have for this section. Just to recoup, so what you guys can experience here, we know how can we load an image, colored image. Okay. We know how can we get the shape of the image. We know now that we know a colored image actually consists of 3 layers. Okay. We know how can we convert using OpenCV from grayscale to colored image. And then how can we take the actual gray image and save it, you know, in an actual image, which is perfect. Now I can, you know, take image from working directory, play with it, do something with it, save it back to the working directory. All right. I hope you guys enjoyed that section, and see you in the next section.